Sorry I'm not there again today. My son was nice enough to share his germs with everybody. So hopefully I will be there tomorrow, but we are going to continue using applications or solving application problems for exponential logarithmic equations. We are going to use the same four formulas that we used yesterday. The only difference is this time we're, for the most part, going to be finding time. So let's read this, decide what formula we need to use, and then figure out how to solve it. If you deposit $5,000 into an account paying 6% annual interest compounded monthly, how long until there's $8,000 in the account? Okay, so we're starting with $5,000. We have 6% annual interest compounded monthly, and final amount is $8,000. So we are going to go ahead and use the compound interest formula. And plug everything we know in. Okay, so this time we're given our final amount, which is $8,000, and our principal, which is $5,000. Our rate is 0.06, and monthly means 12. So if I plug all of that in, I'm looking for the t this time. So we're going to do a little bit of simplifying here, and we're going to have to use logarithms this time to solve. So I'm going to start by dividing by 5,000 on both sides. So 8,000 divided by 5,000 gives me 1.6. Okay, I'm also going to simplify this on the inside, so I'm going to do 0.06 divided by 12, and then add 1. So I get 1.005 to the 12t power. Okay, now, since we have a variable in the exponent, what we're going to do is we're going to change this to a logarithm like we did when we solved equations last week. So my base is this, and then my exponent. So log base 1.005 of 1.6 will give me 12t. So we're going to type that into our calculator. We're going to do log of 1.6 divided by log of 1.005 and get 94.236 equals 12t. And then if you divide by 12, you get 7.85. And we're looking at time, so this will be years. Okay, so big difference here. When you're plugging it in, we don't know our time, so to solve it, we're going to have to follow a few different steps and use logarithms to be able to actually get the answer. So log of 1.6 divided by log of 1.005, and then go from there. Next problem. A coin had a value of $1.17 in 1995. Okay, so the coin had a value of $1.17 in 1995. Value has been increasing by 9% per year. And what year will the coin be worth? $2.75. If it's increasing, we're going to use exponential growth. So A of t equals initial amount times 1 plus the rate to the t power. So final amount is going to be $2.75. Initial amount is $1.17. I'm not sure what just happened there. The rate is 9%, so 0.09, and to the t power. So I'm going to go ahead and simplify. I'm going to divide by $1.17. So 275 divided by 117 is 2.35. And if I add the stuff in the parentheses together, I get 1.09. So now that I get to this point, the variable is in the exponent. I need to rewrite it as a logarithm. So we're going to do log base 1.09 of 2.35 to the t power, or equals t. and then plug that in our calculator. So log of 2.35 divided by log of 1.09 is 9.9. So about 10 years. So in what year, though? 10 years later would be 2005. Okay, so again, rewrite it as a logarithm. Use your calculator, change the base or the shortcut in my calculator, and then make sure you answer the question that they're asking. Next problem. An isotope of cesium-137 has half-life of 30 years. Okay, so we're looking at half-life of 30 years. How long would it take for a 2.5 gram sample of cesium-137 to disintegrate 2.025? So half-life. And I'm going to go ahead and plug my half-life in there. Half-life is 30 years, so we're going to do 0.025 equals 2.5 half-life of t divided by 30. So if I divide by 2.5, 0.01. Sorry, 0.1. Okay, and then again, once we get to this point, we're going to rewrite it as an a logarithmic function. So log of 0.5 of 0.1 equals t divided by 30. So if I type that in my calculator, log of 0.1 divided by log of 0.5 gives me 3.322. And to actually find out how long it takes, we're going to multiply by the half-life, so times 30 on both sides. So we get about 100 years. So this is 99.66 years. One last problem. In 2010, a manufacturing company purchases a piece of equipment for its assembly line for $175,000. If the value of the equipment depreciates at a rate of 18% per year, when will the equipment be worth $4,000? So this time we're using depreciation or exponential decay. So we want to know how long it takes before it's depreciated to a value of $4,000. From the original value of $175,000, 18% is 0.18 as a decimal. So we're going to go ahead and simplify. I'm going to divide by 175,000. Okay, so 4,000 divided by 175. 175,000 is 0.023, and then 1 minus 0.18 is 0.82. So now we're going to rewrite this as a logarithm. So log base 0.82 of 0.023 t power equals t. So 0.023 log divided by 0.82 log is 19. Okay, so that's pretty much what we're doing today. Work on that worksheet. Like I said, I hope to be at school tomorrow so we can go through all of this. We will be reviewing for a quiz tomorrow and then taking a quiz on Thursday. There are 4 guided practice problems. If you want to work on those with a partner to check it out, make sure you understand it. You can go through them together. Then once you're ready, go ahead and start your homework. Have a good day.